Well, I had told you that we were going to spend a good deal of time in this module discussing friction, and today is the day when we're going to do that. We've already talked about how the fact that friction is a force, and we know that it opposes motion. And we also know, just because we know what friction is, we know that friction results from the fact that two surfaces are in contact with each other. And if you think about that on a molecular level, an object appears to our eyes to be perfectly smooth. But in reality, and there's a picture in your book that illustrates this, down on the molecular or atomic level, there is no surface that is completely smooth. And depending on the surface, some surfaces are much less smooth than others. Depending on some surfaces, we can actually feel that with our hands. And even though some surfaces may look perfectly smooth, like maybe a tile or a linoleum floor may look perfectly smooth, in reality they're not. And so what happens is that you have an object that's trying to move along of another object, but in reality, you've got little atoms and molecules that are kind of sticking out from the surface here, and there's also some that are kind of sticking out from the surface on the bottom, and so they actually are going to kind of catch on each other, and then that's what's going to cause your frictional force. Now, there are two types of friction. You've got static friction and you have kinetic friction. We know from experience that it is harder to get an object to start moving than it is to keep it moving. The type of friction that has to be overcome to start an object moving is called static friction. And kinetic friction is the friction that has to be overcome in order to keep an object moving. Now, static friction is always greater than kinetic friction for a given object and a given surface. And again, if we think about that at the atomic level, it makes sense, because if an object is just sitting there, then the molecules have time to kind of nestle into each other. They're attracted to each other, so they have time to sort of nestle into each other and really kind of get firmly entrenched. Whereas once an object has started to move, they're still kind of catching on each other, but they don't have time to really settle down and really get caught really good, I guess you could say. So static friction is always going to be greater than kinetic friction for a given object and the surface on which it is sitting. Static friction is going to vary depending on how much force you apply. So if you have, again, our standard box sitting on the floor, you give it a little shove, it doesn't go anywhere. You give it a bigger shove, it doesn't go anywhere. You give it a little bit bigger shove and it still doesn't move. And eventually you give it a big enough shove and it will start moving. Now, we've talked about before how if something is not moving, that means that the vector forces on it are equivalent to each other and they cancel each other out. So what that tells us is that the static frictional force is going to vary. So if you push a little bit, then the static friction pushes back a little bit. If you push a little harder, then the static friction pushes back a little harder. Eventually, though, that static frictional force has a maximum value, and once you overcome that maximum value, then your object is going to start to move. So static friction varies depending on the applied force, but it has a maximum value, and once you overcome that maximum value, then you're going to be able to get your motion started. Friction always depends on the nature of the two surfaces that are in contact with each other. And so I think that, again, is something that you already are familiar with. If you think about putting a box on pavement and think about how easy it is to shove there versus if you put it on carpet. Or how about if you put the box on a smooth tile floor? How about if you put the box on a really rough board? How about if you put it on concrete? So all of those different surfaces are going to make the box either more or less easy to push depending on the nature of those surfaces that the box is actually sitting on, okay? Now, again, from experience, we know that the heavier a box is, the harder it is to push. And again, from the atomic level, the heavier it is, the more the weight is going to cause it to settle into the molecules of the surface. And so they're just going to get that much more firmly entrenched, and it's going to be that much harder to dislodge them in order to get that box to move. We also know that the weight is proportional to the normal force, and so therefore the frictional force is going to be proportional to the normal force of the object But that's not something we're going to get into until tomorrow.